Welcome to a new part of the ISM Statistics 1 exercise set, this time with an exercise on measures of central tendency. Let's take a closer look at the exercise. The following sample results from asking students how many hours a week they watch online shows. What's to do with this data set? First off, prepare a frequency table, calculate the mode, calculate the median, and calculate the arithmetic mean. However, before we even can start with part A, we need to do one more step, and this means we need to consider our data set and order this in an ascending fashion. So we start with the smallest values, that's 2 times the 0, then 1's the 2, 2 times the 3, and the other 5 values, the 4, the 10, the 12, the 24, and the 31. So we can use this arranged, disordered data set to better calculate and solve all the main parts of this exercise. So we copy this ordered data set and then we construct a raw frequency table. Raw means without any entries up to this point. We need 4 different columns. First off, to put into the values, second one for the absolute frequencies, third for the relative, and the last one for the cumulated relative frequencies. Here we need to take care that each value is only entered once. So even though we have the 0 and the 3 for 2 times, we only enter them once. Also, the absolute frequencies then measure how often the value occurs in the actual data set. Here for the 0 we have 2, for the 3 we have 2, but for all others we have 1. If we were to consider the overall amount of data points, or the sum of all absolute frequencies, and divide the absolute frequencies by this number of observations, we get our relative frequencies. Here we have a sum of observations or number of observations of 10. So if we divide the absolute frequencies by 10, we get our relative frequencies. So this leaves us only with the last column of the cumulative relative frequencies. For this, we always take the cumulated frequency of the row above and add to this the relative frequency of the current row. So with the first entry, well, the row above, there's nothing, so we have 0, plus the relative frequency in this row is 0.2, resulting in 0.2. To this 0.2, we add the 0.1 in the row for the 2, and we get a result of 0.3. To the 0.3, we add the 0.2 for the row of 3, and get a result for cumulative relative frequencies of 0.5. We do this for all the other entries. The only important thing, we need to take care that at the end we arrive at 1.0, because this means we have achieved 100%, and this is what actually needs to happen all the time. If you do not arrive at 1.0, something might have gone wrong in the way. Okay, however, this is the frequency table we needed, the frequency table we were asked to construct, so we can get to our next part. In the next part, we're actually going to use this frequency table to calculate the mode. What's the mode? The mode is the most frequent value, so the value with the largest absolute frequency. Here we can see we have absolute frequency for the value of 0, and we have an absolute frequency of 2 for the value 3. So our mode in this context is not unique. So we either have the possibility, as we do it here, to say the mode is 0 or 3, or we could just say there is no unique mode. Both things are acceptable. Here we decide on listing both of them. Okay, this then already concludes half of the exercise. Let's carry on with the third part. Third part was on calculating the median, and for this we used the ordered data set. If we want to calculate the median, however, we need to consider that there are 2 formulas for the median. And, well, they depend on how many number of observations I have, or rather whether I have an even or an odd number. Here, as we said, we have 10 observations, so we have an even number of observations, meaning we need to use the first formula. For the first formula, we have the two indices, 0.5 times n, which is then 5, and 0.5 times n plus 1, which is actually 1 larger, so it's 6. Meaning we need to consider the fifth and the sixth observations, add them up, and multiply them with 0.5, or divide them by 2. This is what we're actually going to do here. We add 3 and 4, the fifth and the sixth data point. 3 is the fifth data point, 4 is the sixth data point, and divide them by 2, leading to a median of 3.5. Having concluded the exercise on the median, we can carry on with the arithmetic mean. And for this, we again consider the ordered data set, because the easiest version for the arithmetic mean is just by adding up all the data points and dividing them by the number of observations. So here we would add up all the numbers and divide them by 10, the number of observations, leading us to a result of 8.9 for the arithmetic mean. This works easy, or is an easy way to calculate this, simple way to calculate this, if we only have a limited number of observations. Might become more problematic if we have quite a lot of data. So in the next slide, I will propose 2 additional approaches to calculate the mean if you have a lot of data points, in particular a lot of data points which repeat after a certain time. So the first alternative for the arithmetic mean we will see bases itself on the frequency table. Here we just multiply the values and the absolute frequencies. We add this up and divide this by the number of observations. This leads to the following result. Well, obviously the result 8.9 is the same as before. Why would it make sense to actually use this approach? Well, if we have a lot of values with absolute frequencies larger than 1, we could save a lot of time. Instead of always adding them up, imagine adding up the same value 100 times. Instead of doing this, you just go calculate 100 times this value. So it could save, for large data sets, a lot of time. Well, so could the second approach, which also uses the frequency table. And it's basically the same as the approach before. The only thing which we do here is we do not multiply the values with the absolute frequencies and then divide by the number of observations. We instead multiply the values with the relative frequencies. Well, considering how the relative frequencies are calculated themselves, it's basically the same as alternative 1. However, it's slightly, considering what we calculate, it's slightly different, and it saves some operations. So it could again be beneficial if you have a really large data set. And well, obviously we get the same result as before. So this then concludes not only the fourth part of this exercise, but the whole exercise. And I hoped all of you enjoyed listening and learned something. Until next time, see you and goodbye.